Engineering Mathematics 3. Before solving numerical problems, let's see what is a Laplace transform and how it is defined. First, Laplace transform. It is denoted as a L. It is denoted as a N. Let f of t be a real valued function. Here f of t is a any function, real valued function defined for t is greater than or equal to t 0. Then the Laplace transform of f of t is denoted as Laplace of f of t. Here L is Laplace and f of t is any real value function. This is defined as integrating from 0 to infinity e raised to minus st into f of t with respect to dt, and this is denoted as this is called as a f of s, where f of s is a frequency domain and f of t is the any function, real value function. Let's see what properties of the Laplace transform. First property, Laplace transform of a into f of t. This can be written as, here a is a constant. Let's take a is outside the bracket, a into Laplace transform of f of t. This can be written as a into Laplace transform of f of t. And then second property, Laplace transform of a into f of t plus or minus b into g of t. This can be written as a into Laplace transform of f of t plus or minus b into Laplace transform of g of t. Here a and b are the constants, therefore I will take an outside the Laplace. And third property, Laplace transform of f of t into g of t is not equal to, this cannot be written as Laplace transform of f of t into Laplace transform of g of t. This is not equal to, this cannot be written as in this type. Get clear? And then see what are the standard results of Laplace transform. Here is table is there for Laplace transform f of t. First serial number f of t and Laplace transform of f of t. Here f of t is the functions. Here f of t is 1 is there, a is there, e raised to at is there, e raised to minus at is there, cos hyperbolic at, sin hyperbolic at. Laplace transform of 1 is 1 by s. Laplace transform of a is a by s. Laplace transform of e raised to at is 1 divided by s minus a. Laplace transform of e raised to minus at, this can be written as 1 divided by s plus a. Cos h means hyperbolic. Laplace transform of cos hyperbolic at is s divided by s square minus a square. Similarly, sin hyperbolic at is written as a divided by s square minus a square. Here a is a constant. Similarly, this is cos at, simply cos at, this can be written as s divided by s square plus a square. In this cos hyperbolic at, s divided by s square minus a square is there, and cos at s divided by s square plus a square is there. So look carefully. And then sin at, Laplace transform of sin at can be written as a divided by s square plus a square, and Laplace transform of t raised to n can be written as gamma of n plus 1 divided by s raised to n plus 1. If n is integer, that means positive integer, here this can be written as n factorial divided by s raised to n plus 1. I tell you how this come. Laplace transform of a is a by s and e raised to at is 1 divided by s minus a, and so on. Here I can only solve only two functions, that is a and e raised to at. So first one, Laplace of constant, I taken as constant here. Laplace of constant, here a is the constant, I taken as a is a constant. Okay, then Laplace of a, according to the function, Laplace of f of t can be written as integrating from 0 to infinity e raised to minus st f of t into dt. Understanding? Here a is the in place of the f of t, therefore here f of t is a, e raised to, integrating from 0 to infinity as it is, e raised to minus st into f of t. Here f of t is a, dt is as it is. So here a is a constant. Then take outside from the integral, integrating from 0 to infinity e raised to minus st dt as it is. Let integrate above equation, it becomes e raised to minus, integration of e raised to st is e raised to minus st divided by minus s, because s is a constant, therefore it can be divided. And take the limits 0 to infinity. When I put upper limit, it becomes, here s is constant, here minus s is constant, here take outside, it becomes minus a by s. When I put upper limit to the in front of s, it becomes e raised to minus infinity minus 1. When I take 0 as a lower limit, it becomes minus 1. E raised to infinity means 1, and 1 e raised to infinity is infinity. E raised to infinity is 0, 0 minus 1 is minus 1, and it becomes a by s is the final answer. Therefore, Laplace transform of a constant is a by s. If Laplace transform of 1 is there, here a is equal to 1, it becomes Laplace transform of 1 is equal to 1 by s. Get it? And next one, second one, Laplace transform of e raised to at. Here e raised to at is the f of t. According to the definition, Laplace transform of a f of t can be written as integrating from 0 to infinity e raised to minus st into f of t with respect to dt. Here f of t is e raised to at is there, so Laplace transform of e raised to at is equal to integrating from 0 to infinity e raised to minus st. Here f of t is e raised to at is there, so as it e raised to at with respect to dt. Okay, it is in the form of, here base is same, then power can be added, so it becomes 0 to infinity e raised to at minus st with respect to dt. When we integrating and by applying limits, it reduces to 1 divided by s minus a. Therefore, Laplace transform of e raised to at is equal to 1 divided by s minus a. Similarly, you will do for all the remaining functions. Okay, understanding? Then next, solve some numerical problems. So let's start numerical problems. This is the type 1 problems. Find the Laplace transform of the following. First one, 1 plus et whole square. 1 plus et whole square. They ask to find the Laplace transform of this. So take Laplace of 1 plus et whole square. Okay, here it is a f of t, and it is in the form of a plus b whole square. It can be written as a square plus b square means e raised to 2t. It becomes a square plus b square plus 2ab. Okay, then take the individual Laplace of 1, Laplace of e raised to 2t. Here constant is there, so take outside from the Laplace of e raised to t. So in the standard result, Laplace of 1 is 1 by s is there, plus Laplace of e raised to 2t is there. In our standard result, Laplace of e raised to at means 1 divided by s minus a is there. Here a is, in this problem, a is 2. Therefore, Laplace of e raised to 2t is s divided by 1 divided by s minus 2 plus 2 as it is. Laplace of e raised to 1t is there. In place of a, here 1 is there, so into 1 divided by s minus 1. It becomes 1 divided by s plus 1 divided by s minus 2 plus 2 divided by s minus 1 is the final answer. Next one, 3 into e raised to minus 2t minus 2 into e raised to 3t. So Laplace transform of 3 into e raised to minus 2t minus 2 into e raised to 3t. Take individual Laplace for each term. Here 3 is a constant. Take outside from the Laplace, and Laplace of e raised to minus 2t minus as it is. Here 2 into e raised to 3t is there. Here 2 is a constant. Therefore, I will take 2 outside from the Laplace, and Laplace of e raised to 3t is as it is. Here 3 as it is. Here Laplace of e raised to minus 2t is there. By the standard result, Laplace of e raised to minus at is 1 divided by s plus a. Here in the place of a, minus 2 is there. Therefore, it can be written as 3 divided by s plus 2 minus 2 as it is. Laplace transform of e raised to 3t, it can be written as 1 divided by s minus 3. It reduces to 3 divided by s plus 2 minus 2 divided by s minus 3. S minus 3 is the final answer of this question. Next one, Laplace transform of 2 into t square minus t plus 4. Take the each term, take the Laplace. Here 2 constant, therefore I will take 2 common outside from the Laplace, and the Laplace of t square minus Laplace of t plus Laplace of 4. Okay, 2 as it is. Laplace of t square, in general Laplace of t raised to n, here n is positive integer there, so Laplace of t raised to n can be written as n factorial divided by s raised to n plus 1. Okay, in front of n, in place of 1 n, here 2 is there, therefore it can be written as n factorial, means here 2 is there, 2 factorial divided by s raised to 2 plus 1 minus same Laplace of t raised to 1 is there, so 1 factorial divided by s raised to 1 plus 1 plus Laplace transform of a constant means a by 4 by s. Okay, here 2 factorial means 2 plus 1 s raised to 3 minus 1 factorial is 1, s raised to 1 plus 1 is 2, 4 by s is as it is. This reduces to 4 divided by s cube minus 1 divided by s square plus 4 by s is the final answer of this question.